This is Algebra 2 with Trig, 8b.4a. We're talking about evaluating our trig functions. So here today, actually more in the future than today, but we're talking about a circle with a radius larger than 1. Okay, because the radius sometimes won't be 1. And the main thing that changes are the actual coordinates along the unit circle, but the degrees still exist. So when you think about that, here we have a particular angle, and we can form a triangle off of that with an x value and a y value. The radius might not be 1, but our opposite over hypotenuse is still the y value over r. And the adjacent over hypotenuse would be x over r. X is the value that you move to the left of the origin, or right. Tangent is opposite over adjacent. The opposite would be the height, the y value, and the adjacent to our angle is going to be the y. Sorry, the y is the height and the x is your denominator. Working with cosecant. Cosecant is going to be the reciprocal. Reciprocal, so we're going to do r over y and r over x. And cotangent's going to be x over y. So we would call these circular functions. Most of our problems that we're dealing with today, we don't have a specific radius labeled. So that means we're just using the unit circle. The unit circle has a center at 0, 0 and a radius of 1 for what we've been talking about. We can use the knowledge of the unit circle to evaluate circular functions. Remember what we've talked about in the past, that quadrantal angles are angles in standard position whose terminal side lands on an axis. That's going to be 90 degrees or pi over 2 radian. So any multiple of 90. So a quadrantal angle is ones that land on the axes. So an angle that lands on the y-axis positive, that would be 90 degrees, or it could be 180 degrees, 270 degrees, or 360, any multiple of those. Or you could talk about it in terms of a radian, which would be pi over 2, pi, 3 pi over 2, and 2 pi. So here we are. What are your 6 trig functions at 2 pi? Well, think about what does that mean in terms of the unit circle. Where is 2 pi? 2 pi is the same as at 0. So what's the coordinate there? 1, 0. So we can make these determinations without turning to our unit circle. You want to have a visual idea of where this is located. So we have the sine of 2 pi. What we've learned before is the order of our coordinates goes cosine, sine. So the sine is the y value. So the sine of 2 pi is 0. Next we have cosine of 2 pi. Cosine of 2 pi, we're talking about the x value, so that's 1. Then we have tangent of 2 pi. Tangent of 2 pi is the y value divided by the x value, the sine divided by the cosine. 0 divided by 1. That we can do. That's 0.
No, 1 divided by 1.
The reciprocal of this would be undefined, but 0 over 1 is what happens every day. 0 cookies divided by any particular person. So sine, the reciprocal of sine is going to be cosecant. Remember that if it starts with an S with sine, its partner starts with a C. So that's going to be cosecant. It's the reciprocal of 0. Well, what's the reciprocal of 0?
0. 1 over 0.
We have 0 over 1 to start with. So we're going to flip that and go 1 over 0. And that's going to be undefined. Because you can't take one cookie and have nobody eat it. That would just be leaving it. So next we have secant. Secant is the reciprocal of cosine. One starts with a C, one starts with an S, just like here. So they are reciprocals of each other. If we were 1 for cosine, which is 1 over 1, we would be 1 over 1, which is 1. And to finish off, we're at tangent. Actually, it's cotangent of 2 pi. Here we had 0 over 1. Now we're at 1 over 0, which we would consider to be undefined, and we can abbreviate that UND. So that's an example of finding all 6 trig functions when given a particular angle. Now, if the angle they gave you was not on the unit circle, that would make it a little bit more challenging. But all the angles that we're given will be found on the unit circle, or coterminal of that. For example, 270. This is a quadrantal angle. (270) would be all the way around, going straight down. So what's the coordinate that points in that direction? Everyone should have an opinion. Right and left is 0, and your y value is -1. So the sine of 270 degrees is the y value, which is -1. The cosine of 270 degrees is the x value. Because remember, this goes cosine, sine. It goes in alphabetical order, just like x comma y, cosine, sine. Tangent of 270 degrees would be the y divided by the cosine, y divided by x. And that's going to be undefined. Cosecant is a reciprocal of sine, so it's -1. Secant is a reciprocal of 0. 0 is 0 over 1, so we flip that to get 1 over 0. That's undefined. And to finish up this page, we've got cotangent of 270, which is -1 over 1, which we flip that around, and we still get -1. So next we're talking about reference angles. Okay, a reference angle is the acute angle to the x-axis. So when we have an angle that goes to the second quadrant, we want the value that's going to continue to get to the x-axis. That is our reference angle. So that's going to be 180 minus the angle they give us. So if they give us 120 degrees, what is the reference angle? that would be 180 minus 120 degrees, which would be 60 degrees. In our third quadrant, if they give us an angle that goes all the way to the third quadrant, let's say they give us 200 degrees, that's past 180. It takes us into the third quadrant an extra 20 degrees, so the reference angle is 20 degrees. That's going to be your angle minus 180. And then if you're in the fourth quadrant, let's say they give you an angle of 300. They give you an angle of 300, you have 60 more degrees to get all the way to the x-axis. It's an acute angle. We're never going more than 90. So we have 360 minus the angle they give you. If you're in the fourth quadrant, you could use that formula. I'm not a big fan of using any of the formulas, but there they are if you need to refer to them. One of the helpful hints for sure is that a reference angle is always positive. So let's come on over and try what is the reference angle of 7 pi over 12. So we draw our circle. So where is 7 pi over 12? We know that 12 pi over 12 would be over here. We know 6 pi over 12 would be straight up. So 7 pi over 12 will be approximately right there. So how much more do you need to get down to there? To get down to the x-axis? How many more 12s are you missing to get up to 12 over 12? You're missing 5 pi over 12. Well, we could use our formulas. Instead of the 180, we would use a radian version, which is pi. So this is pi minus our angle, which was 7 pi over 12. Of course, you need to be with common denominators. So 12 pi over 12 minus 7 pi over 12 is going to give us 5 pi over 12. And that would be radians. So you can physically calculate it, but I would prefer for you just to mentally think about what does it take. You're at 7 over 12. Your x-axis is going to be 12 over 12, so you need 5 more. So it's 5 pi over 12. 290. Or 295, actually, and it's negative. 295 is obviously more than 270 by 25 degrees more. So there we go. So we're looking for the reference angle, which is an angle that takes us down to the x-axis. So how many more does this take us to get to negative 360, essentially? It would take us 65 more degrees to get there. So 65 degrees, Remember, your reference angle is always positive. It's not a negative 65 degrees. It's 65 degrees is what you would be missing for it to get all the way back to the x-axis. The formula is a little tougher to come up with a negative 295. In terms of a formula we could use, we know that if you continued around in this negative direction, you'd be working with the full distance to get to the x-axis again. It would be negative 360. But we don't want to count the rest of this angle, which is negative 295. So essentially we are adding 295, which gives us negative 65. But we know that a reference angle is always positive, so we have to consider the absolute value of all of those. Again, I think that that's a little bit more intense than just focusing on the amount that it takes you to get back to the x-axis. 210. 210 is larger than 180. How much larger than 180 is it? You can take your 210 minus 180, and you'll see that that is 30 degrees longer. So 30 degrees is your reference angle from the unit circle. Negative 7 pi over 9. Well, negative tells us we're going to be going in a clockwise direction. But where would 7 pi over 9 be? I know that 9 pi over 9, or in this case negative 9 pi over 9, would be there. Negative 4.5 pi over 9 would be halfway. So I know that 7 is landing somewhere in between those. So how much more do you need to go? If you're at negative 7 pi over 9, how many more do you need to get to be negative 9 pi over 9? And that would be 2 pi over 9. Those would be radians. Negative 260. Negative 260 is short of 270. How much short of 270 is it? From negative 270, that is 10 degrees short of 270. So how many more degrees do we need to be to get all the way back to the x-axis? We'd be 10 degrees short of the y-axis, would be 80 degrees short of the x-axis. Now remember, it has to be a positive reference angle. If they're giving it to us in degrees, we should give our answer in degrees. If they give us a question in radian, we should give our answer in radian. Okay, last one. 5 pi over 4. Well, there's or not 5 pi, right? It's 15 pi. We could count our way around that. 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Could count your way around it. You could take the 15 pi over 4, and because that's larger than the unit circle, that's larger than 2 pi, I need to subtract 2 pi. So that means my common denominators have to match. So that's going to be 7 pi over 4. that is less than 2 pi. So that's our 1, 2, 3, 4, 5, 6, 7. That's in the same direction that we had talked about before. But anyway, the main question is how much more do you have to go? So pi over 4 is what we would need to get all the way to what would be equivalent to 2 pi over 4. Because that's what a full circle would be.